So I'm going to welcome our next speaker up to the stage. I think I got the thumbs up. It's Eric Choy from Hiro. He's going to talk about the importance of unit testing. So for Clarity smart contracts, right, the smart contract programming language for the Stacks ecosystem, you got to make sure this stuff works right. And he's going to make the case for why unit testing gives you that extra assurance that things aren't going to completely nuke when you ship your smart contract onto mainnet. So welcome Eric to the stage for this next presentation. Thank you.
Okay, well, can everyone hear me? Perfect. All right, so today's topic will be unit testing Clarity smart contracts. This is essential as, with what the MC said, it's essential for making sure that your Clarity smart contracts work the way that you expect and to avoid any bugs when you do deploy them on mainnet. So, yeah, unit testing Clarity smart contracts. My name is Eric. I'm a developer advocate at Hiro. Bought Bitcoin back in 2017 and realized Bitcoin is needed. I then bought some pixelated ape NFTs on Stacks in 2021 and realized Bitcoin can be fun. And had a little bit too much fun with Stacks NFTs. So this is a picture of me and my wife. We custom printed some t-shirts with our Stacks NFTs on the t-shirt just to show them off a little bit. And yeah, walked around a park and, hopefully nobody tried to rob us or anything, so yeah, and you know what's much more fun than Stacks NFTs? Unit testing. Hopefully you don't get a whiff of my sarcasm, but popular web developer, Theo, he once said, I am much more focused on fixing mistakes when it happens, not catching them by putting more work from the start. This philosophy and mindset is okay for certain startups, and it kind of conforms to the whole startup mentality of move fast, break things. But the thing is, in blockchain, once you deploy to mainnet, you can't go back and fix your issues, right? Smart contracts are supposed to be immutable and forever ingrained in the Stacks blockchain, or in the blockchain in general. So smart contracts are immutable. Untested smart contracts are fallible, right? Going back to what the web developer said before, they can go back, if you're working in the Web 2 space, they can go back, fix the code, fix it in production, and everything will be okay for the most part. When you're working with smart contracts in the decentralized ecosystem, once you make a mistake on your smart contract on mainnet, well, it could be fatal or it could be costly for a lot of your users. So today, for unit testing, the tool that is going to be powering our unit testing is going to be using the Clarinet SDK, which is built and maintained by the Hiro team. For those who don't know, the Hiro team is the open source developer tooling team for the Stacks ecosystem and blockchain. And if some of you are unfamiliar with unit testing, essentially it's a great way to isolate and test your specific functions, verify contracts are working the way you expect, and also it can serve as living documentation for your code. So in today's demo, I'll be signing on to the Hiro platform. I'll explain what the Hiro platform is in a minute. Walk through a campaign funding contract. This is just a sample smart contract that I'll be going through and showing you how to test or make unit tests on that contract. And then we will launch our project via a separate web editor that comes already pre-installed with the Hiro platform. And then we'll be creating unit tests for two different functions, one of them being add campaign and the other being contribute to campaign. These functions, I'll go over them in a minute. And the tools that I'll be using today are, one, the Hiro platform, which can be found at platform.hiro.so. And the other one is, like what I mentioned before, our open source Clarinet SDK library. which is part of the Clarinet suite that we have. All right, so the demo time will consist of a short little live demo where I'll be going through the unit tests and showing you how you can run them and how you can, I guess, create them. Okay. All right, so what I mentioned before, the main tool that we'll be using today is the Hiro platform. For those who are unfamiliar with the, well, actually, let me log out for a second so you can see the beginning. Yeah, so the Hiro platform, it is our cloud-hosted developer experience tool, provided, built, and maintained by the Hiro team. It's essentially your all-in-one toolbox for building, testing, debugging, and deploying your Clarity smart contracts to the Stacks blockchain. There's a lot of very useful and important features of this platform that can really streamline and help your whole developer experience be seamless. So I'll go ahead and sign in. And as I mentioned before, today's demo will be working off of a campaign fundraiser smart contract. There might be a lot of code in here. If you're not familiar with Clarity or whatnot, you can definitely check out our tutorials online, either from the Hiro docs or the Stacks docs. But like I mentioned before, we're only going to be focusing on two functions of this smart contract. One of them is going to be the add campaign function right here. To kind of summarize the logic in this function, it's essentially going to be allowing a user to create a campaign. So any campaign, meaning if they want to raise funds for a local charity, or if they want to raise funds for a new startup, they'll be using this function to create that campaign in the smart contract, which will then allow other users to come in and donate their Stacks tokens for that campaign. So the function logic right here is just going to be going through, taking in those parameters of the campaign title, the funding goal in Stacks, and the number of blocks until it ends, meaning the expiration time until that campaign ends. The rest of the function logic is just going to be updating a few different maps and making sure that the campaign hasn't been created before and whatnot. At the end of the function, which is important here, the end of the function will return a response type of OK, and then that new campaign ID. So remember this, because this is what we're going to be testing for in our unit tests. This public function add campaign will return a response type of OK with a wrapped value of the campaign ID. The next function that we'll be testing for is called contribute to campaign. This function will be allowing other outside people, other users, to contribute their Stacks tokens for that new campaign, which was created by somebody else, right? So in this function, once a user calls it, they'll be identifying which campaign they want to contribute their funds to, and then they will specify the amount of their funds in microstacks. The rest of the functions will just be calling a bunch of assert statements and updating a few different maps. And like similar to the other function for add campaign, this will also return a response type of OK, but with a different wrapped value of a Boolean, which will be true. All public functions in Clarity must return a response type. So in this function, contribute to campaign, or even the other function, add campaign, it will return, it needs to return a response type either of an OK response or an error response. But for now, in the unit test, we'll be looking for the OK response type. So to get started with the unit tests, we won't be building the unit test here in this interface. Actually, we'll be using a separate web editor, which you can simply access from the platform's UI. This web editor, it is a out-of-the-box pre-installed developer environment with a Clarinet project pre-installed. All of your project files are right here. Everything that you need, from your contracts to your deployment plans, to your settings, and to your tests. This is our Clarinet project, which is another tool that we have, kind of the encompassing tool for unit tests. But every project in your platform is essentially a Clarinet project behind the scenes. This web editor allows you to edit and, I guess, dive deeper into your project when using this web editor in the platform. And again, this is also cloud hosted, meaning that you can access this anywhere that you want to, anytime. It just provides a very seamless experience for the developer, meaning that there is also no local development hassles, or there's no software installations needed. It's just all here provided for you in the cloud. Okay, so let's start with unit tests. So we have a unit test file already set up. I'll kind of go through from the top to bottom, and then we'll be constructing our test suites. So in this file right here, campaignfunder.test.ts, let me make it bigger a little bit if it's too. Yeah, okay. All right, so yep, in our test file right here, campaignfunder.test.ts, we're going to be importing a few things from vtest. So just a little bit of background. vtest is a popular JavaScript unit testing framework. Clarinet integrates with vtests to make it a lot easier and familiar for developers to unit test on their contracts. We have it configured so that when you do open up the testing suite or Clarinet, our configuration is all built into this file right here, config.js. Essentially, it's doing two things. It's making a global variable called simnet available in each of your test files. And then it's also loading up custom vtest matchers for you to use when you want to make an assert statement. I'll show you this more in a second. But yeah, so for your unit tests, we're going to be importing a few different tools from vtest and from Stacks Transactions. And then so on line 4, like I mentioned before, simnet, this simnet variable right over here, it is available in each of your test files. It is a pre-configured lightweight Stacks blockchain environment that you can use in your test files. It's very lightweight, and it's essentially a Stacks blockchain right in your test files. And with simnet, it comes with a bunch of different methods that you can use in the same way where you want to interact with Stacks blockchain on mainnet. So simnet, you just type in simnet. You can call public functions. You can call read-only functions. You can deploy a contract. You can also get accounts and get assets. And then so right here in line 4, we're going to be retrieving some accounts that simnet provides to us. Simnet is providing us 10 different accounts that we can choose from. Basically, they're kind of just like testnet faucet wallets that you can use to iterate and interact with your smart contracts in your test files. And then so we'll be getting 2 different wallets, wallet 1 and wallet 2. We'll call it, and we'll just call them address 1 and address 2. And we have 2 different helper functions over here to kind of make things a little bit easier when we go through the tests, unit tests. So the way that we're going to be building our unit tests is that we're going to be using the concept of a describe and it construct. Essentially, we're going to be describing what Clarity smart contract function we're going to be focusing on, and then it will do something in this scenario. So for example, for starters, let's build one right now. We will describe a, checking the status of simnet. And then nested within this describe block, you will then want to check what it will do in your particular specific scenario. So we're going to check the status of SimNet, and it will return a block height for us. So we'll be using this it block over here to specifically test what we want to look for. So we're going to ensure that block height of 1 will be returned. Okay. And then so with this describe an it construct, we could then narrow down our unit tests to individual items, with describe being the grouping of what these specific scenarios pertain to. And then from there, we want to expect simnet.blockHeight to be defined. Okay, so we want to make sure that the block height will be defined when we run this specific unit test right here. And so in order to run your unit test, you can just go to the command line and then run npm run test. And yeah, it works. It passed. So, with this test in place, we can now be sure that the SimNet will be returning a block height when it does run in our test suites. So to go back to our smart contract that we want to test for, like I said before, we're testing two different functions in the smart contract. One of them being is to add a campaign or create a campaign, and the other being allowing users to contribute their funds to that same campaign. So for a lot of these unit tests right here, I've already kind of typed them up just to make it easier for this presentation. Okay. So to summarize, what we have here is we are describing what function that we're going to be testing for, which is the add new campaign. And specifically, we are going to be hoping that it does a few different things. One of them being it returns no campaign found upon contract deployment. It will ensure that adding a campaign, it returns an OK response. And that it will ensure that a new campaign is added. So for the first it block, okay. So for this it block, we want to make sure that there is no campaign at all on the contract. Once you deploy your contract, we want to make sure that the contract is, I guess, clean of any information, right? We want to make sure that we communicate to our users that this contract hasn't been tampered before deployment, or it hasn't been secretly setting up its own campaigns on the contract. So this is what we're going to test for. So we're going to call a read-only function by calling that method on the SimNet object. We are going to test to see if a campaign of number 1 is found. And then we will then take that result and then compare it to make sure that it returns an error that we expect it should happen. So in this read-only function, we're going to say, hey, can you see if campaign number 1 exists on the smart contract or not? And then right underneath it, we can write our expect statement. And with our custom v-test matchers, which already comes via the Clarinet SDK, we're going to be using the custom matcher of 2b error. with a wrapped value of the error code, which is 2 in our case. So to go back down to the terminal, we're going to run this test, and we're going to see if it passes or not. And it does. OK, good. Yep, on the first line here, returns no campaign found upon contract deployment. So that's good, right? We want to make sure that when we deploy the contract, the contract is completely clean of any campaigns. So for the next unit test that we want to write, we want to ensure that adding a campaign returns that OK response type. So first off, we're going to call the add campaign function. This function right here in this line, 44, is going to create a campaign on the smart contract. So what we want to do is we want to check to see if the return value of that function will be an OK response type. So we can use an expect statement, pass in the return value from calling add campaign, and then we expect it to be OK. And in the wrap value, we also expect that campaign ID to also be returned. So we can use a CL namespace, which provides you with a lot of building and parsing clarity value functions. And then in this case, yep, it passed out. So on this line over here, our unit test of ensuring that a campaign returns an OK response passed. All right, so that's good, right? Now we understand and we for sure know that any user can create a campaign on the smart contract. The next unit test is that we're going to ensure a new campaign is added. And with this unit test, we're going to make sure that a new campaign is added by comparing the campaign data with the campaign data that we expect it to be. So I'll just uncomment out these lines of code. And then so like the one before, we're going to be calling add campaign again. Within each if block, SymNet is reset. So you need to perform some of the functions that you might have done before. We're going to be calling the add campaign function again. We'll then read a map key value entry on the smart contract. This map entry should return us back that campaign data that we created. And then this tuple over here is something that we constructed ourselves. Essentially, we're going to be saying that, OK, well, what we think is going to come out from this map value is a tuple that lists the owner, the title of the campaign, the funding goal, and the expiration block. So we can go ahead and write our expect statement to compare the map value from what was returned from reading the map on the smart contract to, well, in this case, we're going to expect it to be an optional type. And in our case, when reading maps on smart contracts, the type that it gets returned is an optional type with a wrap value of that value that you're trying to look for. To be some expected map value, which is pertaining to the tuple that we created over here. So we can go down to our terminal, run npm run test again. And it works. So all three of these unit tests work. We made sure that, one, no campaign was found on the contract once you deploy your contract. The second one is that we ensured adding a campaign returns an OK response. And number 3 is that we ensured that adding a new campaign, that campaign's data once you created it, is equal to the data that you expect it to be if you were the campaign creator. I have a few more different tests at the bottom, but it looks like we are kind of running short of time. But I can kind of quickly go through it just because I mentioned it before. So the first describe block that we did was testing the add campaign function. This describe block is going to be testing for that contribute to campaign function. And then with it, we are going to ensure that the campaign total matches the first contribution, ensuring that the donor contributes the specified amount that they did. This is a great way to make sure that the contract's not doing anything funny underneath or pulling out more tokens than expected. And then also when unit testing, it's also good to maybe prepare for scenarios of edge cases. So testing that something should not do. So in our case, in this last if block, we're going to test to make sure that if a donor wants to contribute to an expired campaign, that it should basically return an error type, meaning that a donor cannot contribute to this campaign anymore because it has ended. So yeah, I mean, I can run the tests for these just so you can see if it passes or not. So we'll just npm run test one more time. Yeah, and it all passes. So our grouping of testing for the add new campaign function and also contributing to campaign works out based on the specific unit tests that we made for those particular different edge cases or scenarios. And then there's a lot of other tools that you can use within Clarinet too. You can look for the code coverage. You can also look to see how much different functions would cost in terms of how much stacks you would need to pay for a particular fee for that function, if you were to call it, and a lot more other tools that you can find if you were to use Clarinet on the platform. So yeah, to go back to the slides. Yep, the tool that's powering the unit tests for Clarinet is our Clarinet JS SDK. There's a blog about it written by Hugo, who is our technical lead for Clarinet. And yeah, thank you. So if you guys want to get started with coding in Clarity and making unit tests and exploring the fun out of creating your own unit test scenarios, head up and sign up on the Hiro platform.